Hello, we are going to graph functions today. To start out, a linear function is any function that the graph creates a line, hence linear. Okay. We're also going to introduce something called function notation. So we talked about what it is to be a function. Your x values can't repeat. Your graph passes a vertical line test. But an equation is going to use this function notation. So function notation looks like this, f parenthesis x. And we say f of x. So this is f of x. It's the exact same thing as y. So normally our equations are y equals 2x plus 5. Well, now we're going to substitute that y with f of x. So it would be f of x equals 2x plus 5. Okay, anytime you see that f of x notation, it will always mean that your equation is a function. So knowing that our linear functions are going to form a line, we can define our linear function with an equation, and that's f of x equals mx plus b. So we're going to graph the line y equals x. Well, in function notation, that is f of x equals x. So in order to graph this, we're going to have to make a table. Well, again, we did this a couple lessons ago. When you make an xy table, you get to choose your x values. So I'm going to use my standard -2, -1, 0, 1, and 2, and I'm going to plug those back into my function. Either one of these equations, they mean the exact same thing. So if my x is -2, that means my y is also -2 since they're equivalent. -1 equals -1. When x is 0, y is 0. And then likewise with 1 and 2. So I went ahead and plotted those points. And then we can verify that it's a function using that vertical line test. And it passes a vertical line test, so it is a function. Okay, here's another one. Y equals f of x equals x squared. Remember, that's the same as y. So when I go to graph x squared, again, I still use my standard 5 points. Now, this y is the same as f of x. So if you want to put in your table x and then f of x, you can do that. But I'm just going to plug in -2 squared. Well, -2 times -2 is 4. -1 squared is 1. 0 squared, 1 squared, 2 squared. So I plotted those points, -2, +4, -1, 1, 0, 0, 1, 1, 2, 4. Those are a curved sort of line, so it's what we call a parabola. Is it a function? Well, again, you're given a graph, so does it pass the vertical line test? And it does. So yes, it is a function. Okay, a couple days ago we also talked about domain and range. So we're going to look a little further at domain and range. This time we're going to look at graphs. So here's our graph, and we're supposed to list or identify the domain and range. Well, earlier our domain was individual points. Here, however, we just have a line segment or a curved segment. So remember that your domain matches up with your x and your range matches up with your y. So when I go to list my domain, I have to figure out what are my x values. Well, x is this horizontal axis. So if I start over here on the left, I have no x values thus far. Okay, still no x values, and then I hit this point. Here is my very first x value. And then if I move to the right, there are points for all of these x values as well. So our domain is going to be any x that is greater than or equal to 0, meaning there's no negative x values over here. Okay, our graph is only on the positive x's. Okay, our range deals with our y. So I start at the bottom of my y-axis and I move up. I don't have any y values, no y values, no y values. Here, I hit a y value. Well, that's 1. And then if I keep going up, there are y values that correlate to these positive y values. This is going to continue to grow, continue to go in an upward movement. That's hence the arrow. So we can say that our range is greater than or equal to this positive 1. Okay, another graph. This is another parabola. We're supposed to find the domain and range. Well, our x values left to right, these have arrows, which means they're going to keep going out, gradually, but they still move out. So there is no point, like on my physical graph, there is not an x value right here. But if you were to keep drawing this forever, eventually it would get out here. So our domain is all real numbers, and that's this symbol. So that stands for all real numbers, which means it's any x value you could possibly imagine. It's 125, it's negative 3/4, it's 0.72, it's negative 1/8. Okay, any x value you could imagine is on this graph somewhere. And then our y values, or our range, again, start at that y-axis. I don't have any y values until this point. So our range has to be y greater than or equal to -1, because all of our y values are above that -1 point.